next topic is kinematics. Right. Uh, in mechanics, we have the study of motion of the particles. Okay. Uh, Kinematics, that's a part of mechanics, right? Is a branch of physics that deals with the motion of particles, right? If the kinematics is considered, then the kinematics is basically a branch of mechanics that deals with the motion regardless of what is causing the motion, right? What are the reasons? We don't have to worry about that. Simply deal with the properties of motion such as velocity, acceleration, so on and so forth. Okay, so kinematics is going to deal with that. Now we need to consider some of the aspects of motion when we are dealing with the kinematics. Now, the direction of the velocity is in the direction of motion, right? So whenever I consider motion, the first point that comes into picture is with what velocity. So the velocity is always in the direction of motion. Okay, but the direction of acceleration is not at all necessarily to be present in the direction of motion. Direction of acceleration is in the direction of net force acting on the body. That's all. So velocity is in that direction, but acceleration, because velocity and acceleration are the two fundamental quantities that we are trying to measure whenever we are dealing with the what you call the motion. Okay, so acceleration is always in the direction of the net force acting on the body. Okay, so overall, with respect to the directions of acceleration and velocity, we see. So this actually means that not necessarily not necessarily in the direction of motion. Okay. The next point. If at all the motion of the body which we are considering is something like along a straight line, then that is called as a one-dimensional motion. Okay, motion in one dimension. It just moves in one direction. So other coordinates x, y, z ಅಂತ ಮೂರು coordinates ತಗೊಂಡ್ರೆ x ಮಾತ್ರ change ಆಗುತ್ತೆ, y, z will not change. So motion happens in one dimension, right? If at all, right, the motion is not in one dimension, then that is called as a curvilinear motion. We'll come to that. So two types, basically two types, but later on we can extend this to 2D, 3D, etc. Right? So motion along one, or I'll write a straight line. This is easier. Motion along straight line, right? This implies it's a one dimension So in that case, we are going to call the motion as one-dimensional motion. All right. If the motion is not in one dimension, not in 1D, implies this is called as curvilinear motion. Okay, I think single L. Okay, curvilinear motion. So the example could be two-dimensional, three-dimensional, etc. Then the next point about this. If let's consider the motion like this. This is the direction in which the object is moving, right? It moves in this way, this way, this way, and so on. So at a particular point, let me consider a point P. Consider this to be the point P. At this particular point, see the direction of velocity is always along the tangent. Okay, direction of velocity is always along the tangent drawn at that point. So this is the V, velocity component. Whereas the acceleration can be in any direction, right? So let me draw acceleration as of now for the time being. Let's say acceleration is in this direction. So this is acceleration, A vector. So I can always have an angle that is represented as theta between velocity and acceleration. Okay, if this theta is 0 less than theta less than 90 degrees, then the velocity will increase. Okay, if this acceleration is making an angle between 0 to 90 degree, the velocity of the particle increases. Whereas if this is, let's say, more than 90, 90 less than theta less than 180, then the velocity decreases. That is because it is the acceleration is causing the system to put some brakes, right? You are reducing the speed. That's why the velocity reduces. You are doing a deceleration. Okay, so these are the basic things we need to understand before we go further about what you call the classification of motion. Okay, let's go for a quick problem. All right, we use what we studied so far. If the velocity is equal to, this is 3 times I cap minus 4 times j cap plus 2k cap meters per second, and say acceleration is equal to 2 I cap plus j cap minus 2k cap meter per second square, because it is acceleration, right? Find theta, the angle between velocity and acceleration, and nature of motion, in the sense whether velocity is increasing, decreasing, etc. We need to find out. So how to find theta now, right? We know that you can use a dot product and calculate, right? So I already know that cos theta is equal to vector A dot vector B divided by AB, right? So first find out A dot B. That is, instead of A, I'm writing V dot A is equal to 3 into 2, that is 6, minus 4 into 1 is 4, then minus 2 into minus 2, so minus 4. 6 minus 4 minus 4, right? This is minus 2. Okay, then v dot e is over. Then okay, magnitude of vector v is equal to under root, this is 3 square plus 16 plus 4, root of 29. Then magnitude of vector a is under root 4 plus 1 plus 4. This is root 9, that is equal to 3. All right. So let's find the theta then. Theta is equal to cos inverse of minus 2 divided by root of 29 into 3. So when you put this into the calculator and calculate the theta, so this is cos inverse of minus 2 divided by 3 into root of 29. Okay, so this comes to be 97.11 degrees, right? So I know that this is, in this case, the theta is falling under the condition 90 less than theta less than 180, right? So velocity reduces with time. As the time progresses, we are trying to reduce it, the velocity reduces because it falls under this condition. Okay, right. So one simple problem we solved. Let's move on to the next concept, right? So here we are going to look at the classification. Classification of motion. All right. So if we look at the dimension, right, based on the dimensions of motion, you can classify as 1D, 2-dimensional, 3-dimensional, etc. Right. Second one is basically it's based on, right, the velocity and acceleration, right? So I can write the v, velocity and acceleration based. So we are not worried about is it one dimensional, is it two dimensional, or is it a three or multi-dimensional motion. We are not worried in the second case, and we are looking only at the values of velocity and acceleration. So based on the velocity and acceleration, you can classify as uniform. First one is uniform motion. Second one, okay, in uniform, I'll write here itself, velocity of a particle is constant, right? And in case of a non-uniform, okay, let me write the point. So in case of uniform, velocity, the v is constant. All right, then the second one is uniformly accelerated. So in this, a is constant. All right, and the third case is actually non-uniformly accelerated. So here, right, none of them is constant, right? Neither v is constant nor a is constant. So v and a not constant. What will be? Because acceleration is changing, continuously changing, so velocity will also change. Okay, so now based on what type of problem we are solving, we might require different types of equations to be used. Okay, so moving further. Okay, let's try to define some of the basic parameters of motion. All right, so the first one is distance and displacement. Okay, so in case of a distance and the displacement, let us consider one diagram to understand the very basic difference. So this is a x coordinate, this is the y coordinate. Let us consider 2 points. One point is over here, this is A. Another point, say over here, this is C. Using the vector notation, I need to draw two position vectors. One is this, and the second one is this. Two position vectors for A and C. Okay, let me assume that there was an object which is at A, it is moved towards B. Okay, and it's moved towards C. Sorry. So this is the direction or the path used to move. Okay, let's assume that the same object actually moves from A to C by a different path. Okay, so this is what I'm going to call as B. Okay, now let us say that the position vector for A is RA, position vector for C is RC, and the difference is delta R. Let me denote it using delta R notation. Okay, it is moving from A to C. Now, what is the equation to find displacement? Displacement is a vector quantity. Okay, displacement is S. So S can be calculated as, we know that it is delta R itself, which is nothing but RC, the destination's position vector minus source from where it started. Okay, now you see it actually, the path it has taken is actually from A like this to reach C. So definitely the path taken, right, is more than the actual distance displacement between A and C. So this, the direct distance is called as displacement, but the path taken is called as the distance. So by obvious reasons, now we know that this is valid. So the displacement, its magnitude is definitely less than the distance. So this is what is very important that we understand from this, because the distance covered from A to C along path B is more, that is called as distance, right, compared to the delta R, which is the displacement, direct path. Okay, then we'll move to the next definition, in which we try to define the two parameters related to the velocity and speed. So I'll call it as average speed, right, and the average velocity. Right. So the average speed is denoted by, so let me write S. Okay, I'll denote it as a, or let's not give a this thing, because we are using the velocity always, we don't use speed. So speed ke yavade notation ಬೇಕಾಗಿಲ್ಲ. I'll simply write average speed is equal to, what is the general equation, is the total distance whole divided by the total time. What is the distance it covered along path B divided by the time taken? That is the speed of the motion. Then if you want to calculate average velocity, then this will be the total displacement divided by the total time. Okay, for velocity we give a notation v. This is equal to, so total displacement could be s by time t, or in case of if you want to give a notation like the delta r, right, by t, that's also fine. So delta r is actually is equal to r final minus r initial divided by time. That's also okay. Okay, this is the time taken. Okay, then there is another quantity related to the instantaneous values of velocity and speed. So that will be our next concept. This is instantaneous velocity and speed. Right. So instantaneous is pretty simple, right? Instead of calculating the what you call instead of calculate the difference and doing this, so we try to define it in this way. Vi is equal to the limit delta t tending to 0. This is change in the speed per change in the time. So this is actually the differentiation ds by dt. Okay, so ds by dt. So if the position vector, say vector r is given, then also we can calculate vi. That is simply equal to dr dt. Differentiate that with respect to time. Okay, so both the instantaneous velocity or speed comes to be the same value. That's why we keep only one equation with us, right? Either ds by dt or dr by dt we can apply. And the next concept under this is the acceleration. So here we have two concepts. First one is the average. So a, I'll give suffix av for average. This is simply change in the velocity divided by change in time. So this is nothing but v final minus v initial divided by the time taken. Okay, and the second one is called as the instantaneous acceleration. That is ai could be equal to, this is apply the limit delta t tending to 0. This is delta v by delta t, which is nothing but dv by dt. You differentiate. So differentiation of velocity with respect to time. First derivative of velocity with respect to time is called as the acceleration. Let's go for a problem. Problem number 1. Okay. If a particle moves from A to B in 4 seconds, calculate the average velocity. So this is the given diagram. It is a proper circle. So this is A. It takes this path like this to reach, this is the point B, and they have given a distance like this. So let's say this is the center of the circle, and from the center of the circle they have given a distance this is 3 meters. So if you want to calculate V average, this is total displacement divided by the total time. So A to B, right, though the path taken is along the circumference of the circle, I don't want that. I want the displacement. Displacement is this distance. So what is this distance? Radius is 3, so diameter is 6 meters. So total displacement is 6 divided by, time taken is given as 4 seconds. So 6 by 4. So this is 1.5 meter per second. All right, here's the equation, is the answer. Right, next, going further. All right. Calculate the average speed from the table given. So there is a table given and we have to use that to find this. So this is the time and this is the speed. So 0 to 2, this is 2. Okay, this is 2 to 5, say 3. Then say 5 to 9 is 4. And 9 to 15, this is 2. So it is very clear that the given data, right, every at a given second, how much is what is the speed it is given. So average speed is nothing but total distance covered, all right, divided by the total time, right? How to find the total distance covered now? I have to use the time into speed to calculate individual distance. So first calculate the total distance. So total distance is equal to 0 to 2. So 2 seconds into 2 plus next 2 to 5, that is 3 seconds into 3. Then 5 to 9, 4 seconds into 4 plus 9 to 15, that is 6 seconds with the speed of 2. So this is 4 plus 9 plus 16 plus 12. That is, I think, 41, right? So this is 41 meters. All right. Now I need to calculate the total time taken, right? So total time is equal to total 15 seconds, right? Because starting from 0, it goes till 15 seconds. So therefore, the average speed is equal to the total distance divided by total time as per the equation. So that is 41 by 15, right? Units meter per second. Okay, let's move to the next question. All right. If the motion of a along x axis is x is equal to 2t square plus 4 times t minus 6, right? Then find the average velocity between t equal to 0 and t equal to 2. Okay, so I just have to calculate the distance it covers between t equal to 0 to t equal to 2 divided by time interval, which is 2 seconds, right? So I just have to calculate. So x at t equal to 0, that means x0 is equal to, I can put t is equal to 0, that is minus 6. So 2 into 0 plus 4 into 0 plus this. Okay, and I'll put t is equal to 2 now. All right, so x at t is equal to 2, I'll call this is x2, that is equal to 2 into 2 square, so 4 plus 4 into 2, that is 8 minus 6, that is 4 into 2 is 8, 2 into 2 square, so 4 is 4, 8 minus 6, correct? Okay, so right, so total value is 10, right? So the average velocity is equal to, so the actual distance covered, right? Distance covered is 10 minus, so the position initial was minus 6, all divided by time is 2, right? This is delta V by delta T, or simply delta V by T. So this is 10 minus minus 6 is 10 plus 6, so 16 by 2. So average velocity is 8 meters per second. Okay, let's move to the next type of question. A curvilinear motion is defined as x equals to 2t square and y is equal to t cube. All right, calculate the average acceleration between t equal to 0 and t equal to 2. Okay, so if x and y are given, it's going to move in multiple dimensions. Better to write it as a vector. So therefore, let's write the position vector. So that is vector r is equal to whatever is the x component multiplied by I plus whatever is the y component into j. So therefore, in this case, the vector r can be written as x is equal to 2t square into I cap plus y is nothing but t cube into j cap. So this means, so we have got the position vector of this particular particle which has a motion as per the given data. Right, now how do you find the velocity? Right, so therefore the velocity is nothing but it is simply dr by dt. So differentiate this r with respect to time. So 2t square has a differentiation 4t. 4t into I cap plus this is 3t square into j cap. That is the differentiation. Okay, v is equal to dr by dt. We got this. But what they have asked the average velocity. Right? It's not instantaneous velocity, it is the average velocity. So average velocity, so VAV is equal to, right, the V final minus V initial divided by the time taken. Time taken is 2 seconds. So let us calculate. Right, so what is V final? V final in the sense it is 2. Put 2 over there in the equation for in the equation of velocity where t is equal to 2. So that is 4 into 2, 8 I cap plus 3 into 2 square, that is 12 into j cap. This is the final value of velocity minus initial value of velocity. Put t is 0, right? So that is simply 0. So divided by the time is 2, time taken is 2 seconds. So the average velocity is equal to, this is 8 by 2. So 4 I cap plus 6 j cap. It's velocity. So not velocity, sorry. It's acceleration. My mistake. Please correct this. This is average A average. So meter per second square. The next concept is called as uniform uniform motion, right? So what are the characteristics? The velocity v is a constant value, right? And in this case, acceleration a is always zero. It is not going to change. Acceleration value, if it comes, it means velocity changes. So acceleration, right, is zero. Then if you want to calculate the displacement, that is always equal to velocity into time. That's the only equation, right? Very similarly, you can calculate the distance is equal to speed into time, right? Assuming no acceleration. Okay. In case of uniform motion, right, we can have the distance, comma, the speed are always positive. It will never become negative, right? Whereas displacement and velocity can be positive or negative. Displacement, comma, velocity, they can be positive or they can also be negative. So these are the characteristics of the uniform motion. Okay, now let's go to specific problems based on this concept. So problem number 1 is okay. Um, a particle travels first half of the total distance okay, total half distance with velocity v1 and the second half and the second half with v2. Okay, question is find the average speed. So let us consider the scenario with the help of a diagram. Assume that these are the 2 points. This is the starting point and this is the end point. Somewhere at the middle, I need to have the midpoint. So first half, it is going to travel with a velocity from between these two. The velocity is v1, and between these two the velocity is given as v2. Okay, so let us say the distance, it's half of the total distance. Total distance is 2d, then this is d, this is also d. Okay, they say that the time, this is with the velocity v1, this is with another velocity v2. Okay, now I want to calculate the time, right? What is the time taken for the first travel of d distance is velocity, sorry, distance by velocity. This is d by v1, and the time taken for the second half, t2, is equal to the same distance d but by v2. So what is average speed? Average speed v, maybe I'll just give you v average. This is equal to total distance divided by the total time. So what is the total distance? D plus d, so 2d. I can write 2d. But the total time is t1 plus t2. T1 is d by v1 plus d by v2. Alright, so let us try to make a common denominator of the denominator, 2d divided by. So this is v2d plus v1d divided by v1 v2. So 2d, denominator of denominator goes to numerator as v1 v2 divided by, this is d common, v1 plus v2. So you can see d cancel. So average speed is nothing but 2 times v1 v2 divided by v1 plus v2. Okay, right, let's move on. The next question. Okay, this is another question. Okay. Particle travels first half of total time with v velocity v1 and the second half with v2. The question is, once again, find average speed. Here it is given in terms of time, right? Previous problem, if you see, that was given in terms of distance, right? So it travels the first half of the total distance ಅಂತ ಕೊಟ್ಟಿದ್ರು ಈ ಹಿಂದಿನ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ. Okay, so but now you see the first half of the total time ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So that's a difference. That's why we are expecting a different answer. Okay, so this is the starting point. Midpoint have the find it. Right, now See, the time is same. This is t, this is also t. But what changes is this is v1, this is v2. So what is the distance, right? The distance d1 in the first duration, first half of the time, the distance covered is velocity into time, right? So v1 into t. What is d2? v2 into t. Okay, so uh, v average is total distance. Total distance is d1 plus d2, correct? Divided by total time, right? T plus t, that is 2t. All right. So this is v1t plus v2t divided by 2t. So take t outside, t into v1 plus v2 whole divided by 2t. So t cancels. So your average velocity in this case is v1 plus v2 by 2. Okay, so that is the expected answer for this particular problem.